So in the last class, we have discussed yeah. So we have classified file foundation. 1 minute. Yeah. Based on the classification, one is based on purpose. So I have said we can use for compacting the soil and for tensile using to resist tensile loads and as anchors. So we have discussed about that classification based on the purpose. So, and second is based on the load transfer. Load transfer, I discussed about that, about frictional pile and end bearing pile, and frictional pile come end bearing pile both. So with the pile which takes load by resisting the load, by resisting the load around this pile surface, that is called frictional pile. If a pile is resisting, these are vertical downward loads anyway, if pile is resisting due to this bearing area, then these are called end bearing piles because the bearing will be at the end. And other one is the pile which resists using both frictional as well as bearing when there is a vertical load. Now, can any one of you tell me when this pile is subjected to vertical uplift instead of vertical downward force? So, what are the forces? What are the resistance force? Where from that resistance uh, will develop? These are frictional piles, and these are end bearing piles. End bearing piles, and these are both. You can write frictional and end bearing both. So now tell me, see, as this the load is downward, the resistance will be upward to compensate. So here also, here load is downward, that's why the resistance is in the upward direction. Here also same, as the load is downward, resistance is upward. So now if the load is itself is upward direction, the pile is there inside the soil and you are applying upward load. So where from resistance will develop? So what are the factors which will contribute? Can anyone tell? See, there is a pile here. You see this pile 1, 2, 3. So you are applying load downward direction. Then what happens? The resistance will develop all around the pile surface as well as at the bottom. Okay, all at both end and surface. It can develop at only surface or at only end bearing or both, and that resistance is occurring in this direction, in the upward direction, because the load is downward direction. Now the load itself is in the upward direction, means you are applying tensile load on the pile. Okay, then what resistance can develop in this pile, but where from? What are those factors which will contribute? Is it friction or end bearing or both? Why not end bearing? Hmm. Yeah, yeah. Correct, correct. So the resistance can come only due to the friction in the upward loading, in the tensile loading. Okay. So now this is all about the classification based on the load transfer. Okay, and method of construction. There are another things. Okay, based on method of construction of the pile. Construction of piles. One is precast, and second one is driven cast into, and third one is poured cast in situ. Okay, can you tell me if you know? You can define, or else I'll tell you. What are precast piles and what are driven cast in situ? What are board cast in situ? Okay, at construction site, at construction site or at workshop. I mean, where those piles are getting. Yeah. So at workshop itself, there is no need to go to construction site. They are already making these piles within the workshop. Okay, that is right. So how do they get installed? Precast piles. Most probably, generally, we go for driving precast piles. See, now I have to define what is driven and what is bored. Then you can answer. See, if there is a ground, okay. Now you are not excavating the soil from ground. You are not excavating directly. The pile is kept here, then it is driven. When it is driven inside without taking the soil out, then soil will move in this direction. Okay, soil gets compacted in the horizontal direction. These are called driven piles when you are not removing the soil but you are installing the pile. So the precast piles generally happen, generally they are installed by driving. So and driven cast in situ. See, by name itself, we can say it is driven pile, and also it is said that it is being constructed in the site. In situ means in the site directly. How is it possible? Can anyone tell? You should drive the pile, but you should construct the pile here in the site directly. Cast in situ means you are constructing directly at the site, not at the workshop. Any idea? Yes, yes. See, there is a land here. Suppose, how do you construct a pile in the site? In the site means it doesn't mean that suppose this is the site. You have to drive the pile here at this location. So it doesn't mean that you are casting the pile somewhere here. Okay, in horizontal position, bringing all those instruments. It's not that. It cast in situ means you are directly constructing in the hole. Okay, and how can it be driven when there is already a hole present? Any idea? Just you can think, there will be a cylinder, hollow cylinder where that is installed first. Hollow cylinder will be installed by driving. So because of that, it is called driven. After installing that hollow cylinder, that in that hollow portion we will pour cement, that mixture of cement and aggregate, all those things. You can say reinforced cement concrete that will be poured once you drive the hollow cylinder. That is called driven as well as cast institute. And board cast institute is very easy. That is just that you will make a hole first, you will take out the soil, you will take out the soil. There will not be any lateral movement of the soil in this case. You are not driving anything, you are just taking out the soil. Okay, you're after taking out the soil, in that you will just pour the RCC, reinforced cement concrete. That's how this will be constructed. So this is the based on this classification is based on method of construction, and other one is based on soil displacement. It is nothing but displacement piles and non-displacement. That's it. Displacement pile means which displaces the soil. These are driven piles. Example, just now we studied, and these are bored piles. So another one is so these are all the things which are about the classification of the piles. The next thing is how do we install piles. So there are some instruments which will be used to install the pile. Simple drop hammer. So the hammer will be just simply dropped on the head of the pile. So it will be done in dynamic mode. Suppose there will be hammer, all those systems, the hammer will be dropped on the head of the pile. That's how the pile is installed. So if different types of hammers will be there, single acting steam hammer, double acting steam hammer, and diesel hammer. So all those things are used for pile driving. And next thing is the main thing which we should talk about, that is the capacity of the piles. So in this class, or generally in our geotechnical engineering, coming to the BTech level, we will talk about only static capacity. So there will not be any dynamic capacity which is taught in this uh, program. So that's the reason why we call them as static formula. Okay. So how many types of soils here we are talking about is two types. One is clay soil and other one is sand. Okay. If capacity is denoted by Q, in shallow foundations we have studied, I have once given this formula. The bearing capacity is CNC plus gamma TF NQ plus of gamma B N gamma, sorry, N gamma. So this is the formula for capacity of the shallow found. Generally in shallow foundations we see this equation. C is cohesion, NC is bearing capacity factor, NC and NQ and N gamma, these three are bearing capacity factors. C is cohesion, gamma dash is unit weight of soil. DF, I have told you DF is the depth of foundation up to from the ground level to the bottom of the foundation. That is DF. So if you combine this gamma dash into DF, that is the effective stress at the bottom of foundation. Now this again gamma dash unit weight of the soil, N gamma again bearing capacity factor. This B is the width of the strip footing. Width of the strip footing. So now coming to the pile foundations, how these formulas will be modified. In clay, friction angle is 0. If friction angle is 0, this term will be cancelled. So then you will be getting, this is only bearing capacity from the end bearing. Okay, this is from end bearing. We don't talk about the frictional resistance coming to the shallow foundations, right? In shallow foundations, we don't have any frictional resistance, only we have end bearing. So this is the formula for end bearing resistance. But in pile foundations, we have end bearing as well as friction. Here also, in sand also, we will be having end bearing plus friction. So this end bearing can be written from this formula. This formula can be used at this place. For friction, we need to write. And here also, this formula can be used to write this end bearing coming to the sand. But friction, we will talk about that. So coming to the end bearing in this portion, as it is clay, these two terms will be cancelled. These two terms will be cancelled. So there will be only C and C. See, we are talking about the force here. This is force, not the capacity in terms of pressure or stress which it can take. So this formula is telling about C in terms of kPa generally or pascals. Okay, NC doesn't have any dimensions, so then it will be in terms of kPa. So if you multiply by the area of the footing, you will get the capacity in terms of kilonewton. So that is the reason why we multiply this CNC with bearing area of the pile. So now we will talk about this friction later formula. Now coming to this Q total will be here. See, in sand C value will be 0. C is cohesion where it exists only in the clays. So if this is 0 in the sand and this will be neglected because this will be very less, N gamma value will be very less. That is the reason why this term will become 0. So we will be left with only this term when coming to the sand, when we are talking about the end bearing resistance. So you can write it as gamma dash or submerged or partial bulk unit weight gamma df into nq multiplied by bearing area, right, plus q friction. We'll talk about this friction later. So now this is nothing but effective stress at the bottom, at the right bottom. You can write q total equal to gamma, sorry, you can write sigma dash nq into AB, okay, plus QF. Now QF in the clays, QF in the sand, we will discuss now that. So QF in case it will be it also develops due to cohesion only. So there will be addition factor which is denoted by alpha. This addition factor, suppose you take clay, here clay particles. Okay. Now these clay particles move or roll one over each other. That's how the frictional resistance develop. Coming to the clays, the friction also will develop due to the cohesion. So here, frictional resistance, frictional resistance, if you talk about directly in the clays, that is equal to cohesion. But here friction is developing in between two different materials. One is pile and another one is clay. So there is a friction in between this concrete material and this clay material. In between two clay particles, the frictional resistance will be equal to C. Whereas in between two different materials, there will be decrease in the frictional resistance. It cannot develop its full resistance as there is another material uh, present. So that decrement is shown in terms of the addition factor. If you multiply this alpha with C, you will get the net frictional resistance along this surface. So that's how QF can be written as in the class alpha into SU. SU is nothing but shear strength. Okay. SU bar you have to take because see we are talking about the resistance due to the friction over the length from here to here. You cannot take one single value at some random point, the SU value. Sometimes SU can be increasing linearly with the depth. Sometimes it may be uniform. So if it is uniform, the average value will be the value at any point. But if it is increasing linearly, you have to take the average between the top and bottom so that you will get the average value of S. So that is this bar will show the average value. Alpha into SU will be the frictional resistance. If you multiply by the surface area, what is the surface area of the pile which is in circular shape? Side surface. Can someone tell if it is D and if it is L? So what is the surface area? Pi D L is the surface area. So this is what the frictional resistance coming to the clays. So now we'll go to frictional resistance in sands. Okay. So here again drawing the same thing. This is sand. There will be at any point if you take there will be some effective stress vertically downward. Okay. So if you want to convert that vertical effective stress into horizontal stress, you have to multiply by earth pressure coefficient. See, I think did we discuss about earth pressure in the class anytime? I don't think. Some, yeah, once I have taught. Yeah, yeah. Okay. So active pressure, yeah, passive pressure, I have taught that. So if you want to find out horizontal pressure, you have to multiply earth pressure coefficient to vertical effective stress, then you will get horizontal effective stress. So there will be three earth pressure coefficients. One is that at rest, and other one is active, and another one is passive. So you have to multiply according to that. If you multiply this K value with sigma V, you will get horizontal pressure onto this pile. But we need vertical reverse, like the pressure or resistance which is in upward direction. Okay, there is a pressure, horizontal pressure, which is acting in this direction. But how does it contribute this vertical effective stress, vertical resistance in upward direction? Can you tell me? Just it, if you take a block, we have studied in our IS school. Suppose there is a block whose weight is, let us say, n. If the frictional coefficient between the floor and the block is mu, frictional coefficient, if the weight is n, so what is the resistance, frictional resistance, when you want to move in this direction? There will be some resistance. What is that resistance? This resistance mu n, right? Means whichever is acting normally onto the floor, that will cause that resistance, right? If you take the more weight, you cannot drag that much because it is contributing the resistance in between this. The resistance will be in this direction, so you cannot move easily. Mu will be constant in between these two material because the material is same here and here. If you take small block, you can move easily because resistance is less, because n is less, the vertical. So the perpendicular load will cause the resistance along the floor by multiplying this mu. So here also there will be a horizontal force or horizontal pressure, that is sigma h, right? How does it contribute this resistance? If you multiply this mu, the mu in between this and this. So what is, how does it, how will it be calculated? Mu is frictional coefficient between these two materials. It is tangent of friction angle between them, between those two um, materials. Okay, you have to use phi here instead of delta when it is only in the soil, between the two soil particles. If it is not between the two soil particles, it is between the two different materials. That is the reason why phi will become tan delta. So if you take tan delta, you will get mu. So if you multiply mu with sigma h, then you will get in this direction. So sigma h will come from the sigma v, and then this resistance will come from the sigma h. So finally, how do we calculate? Mu into sigma h dash is the, where mu is tan delta, sigma h dash is, k into sigma v dash. But sigma v dash, which uh, at which depth you have to calculate this sigma v dash? This depth or this depth, or which depth? Because the resistance is coming all over the surface. You cannot take a particular depth. You have to take all over the depth. That means you have to take the average. You know the effective vertical stress varies linearly, right? You take average, then you take that average value here. So if you multiply by k, then you will get sigma h average. If you multiply that sigma h average here, then you will get the frictional resistance in the sand, right? Is it okay? Fine. Mm, yeah. So let me write full formula. K sigma v dash tan delta. Is it fine? I think it is. This is dash. Okay. This is not -1. This is average symbol. So this is how we will calculate. We can write full formulas now. So place, what can I write? Q equal to CNC bearing plus alpha SU bar or CU bar, you can say A surface, right? And for sand, Q is sigma V dash at bottom NQ plus sigma H dash bar tan delta, right? So this is bearing, this is friction, this is friction, this is bearing, this is bearing, this is friction. Now how to calculate? Suppose there is a circular pile. How do you calculate? AB? AB will be pi by 4 d square. If this is d and this is L, and AS will be pi dl. Sorry, I did not multiply AS here as well as AB here. Pi dl. So this is how we will calculate. I hope you understood these formulas. Okay. Now we will derive formula for, not for, derive, already we have derived, so we'll talk about other pile foundation. They are special because of that under-reamed portion existing at some depth, so those are called under-reamed pile foundations. So how do they look? I'll just show you. A pile has bulb at some portion. Okay, these are specially used in when there is a tensile load. This under-reamed portion will develop extra resistance. See, coming to the normal pile foundation, if you, I'll draw here better. This is normal pile. Okay, so if you apply load, there will be only frictional resistance as we talked, right? Sorry, okay, it will be downward direction. It will be downward direction. Okay, but here you cannot produce any bearing pressure because there will be contact, will be, there will not be any contact when you are applying upward load. But here you can develop frictional resistance, right? As well as this portion will apply bearing resistance, right? See, if you are applying upward load, so this bulb also has to move upward direction. When it is moving, this portion will give downward force. So this is called bearing pressure at the bulb. Bearing resistance at bulb. BULB. This is bulb. This is called as bulb. So there will be some diameter for the bulb, can be denoted by dV. There is diameter for the pile. So there will be some length. So this much portion, okay, you can say LB, okay, and this is total length. This is total length. This is LB. If you see, this frictional resistance will be developed upper portion and bottom portion. Sometimes bottom portion may not involve. Okay, Just a minute. Let me check the question. Uh, okay. See, if they are telling you please neglect the resistance at this portion, frictional resistance, you can neglect. But if they are not saying, you have to calculate the resistance at this portion also. You resistance from the surface will get from this portion and this portion, not this portion. And this portion will not give any frictional resistance. Instead, that will give this bearing resistance, right? So, what is the diameter of this particularly only bulb? If you deduct D from the dB, if you deduct D from the dB, you will get diameter. So, it's like you are deducting this portion. Okay. So, this portion, this annular space will give the resistance to this bearing resistance. Okay. It will act as bearing. So, that portion will give bearing resistance. That portion's diameter is dB minus D. Now, having the knowledge of this, we can find out the formula for tensile capacity. Tensile capacity of the tensile capacity of under-reamed pile. So I'll draw. Okay, upward load. This is L, and this is LB, and this is D, and this is DB. What are the uplift capacity? Uplift capacity will come only from the frictional. Okay, frictional resistance. Uplift, not from the bearing in normal pile foundations. Okay, so I'll write alpha into SU bar into A surface area. So how do you get A surface area? SU bar into pi D, pi D into, can you tell me? Pi D into L minus LB. It's not L, because I told you just now, only this portion and this portion will give you the resistance. This portion cannot give resistance, right? Frictional resistance cannot be given or cannot be developed along this LB length. That is the reason why you have to deduct that LB length. So this is the frictional resistance due to this upward load. Okay. Now, yeah, the L is correct, because as I have asked for the normal piles, you could say that L, yes, right. If it comes to the under-reamed pile, you have to deduct that LB portion. So frictional resistance is fine. And other resistance, what can be added when you are applying upward load? The weight of the pile. If it is W, you can, that weight will also act downward. That will also give some resistance. Weight of the pile. And what other portion from the under-reamed pile? This bearing resistance, right? So what is the bearing? So let me write again. Alpha SU into pi d L minus LB. This is frictional resistance, then weight of the pile, then bearing resistance. in downward direction. CNC, we know that CNC is the bearing resistance. Okay, C at this portion, C at this portion, and NC also at this portion. These are two particular values at this point. They are not average. Average is only here. Okay, because it is all over length minus this portion. So this is the only average thing. Weight is weight, but C and NC values are only at this particular position because the bearing is coming only at this particular position. Okay, CNC. So but bearing area is what? We know the bearing area is in circular shape, pi by 4 d square, but bearing area is coming only this angular space. For that you should db minus d square. So this is the formula for uplift resistance of the under-reamed pile. Uplift. Okay, you know alpha, you know SU bar, so you can take the average, or uniform soil, you can take single value. Pi, diameter of the pile, and length, total length minus length of the bulb, and weight of the pile, cohesion at this portion, and NC at this portion at this particular depth, and pi by 4 into dB minus d whole square. So this is the formula. Okay, so now we will solve one problem. So then we will wind up the class. Okay, so here first we'll read this question. A single under-reamed 8-meter long pile, RCC pile, weighing 20 kilonewton with 350 mm diameter, shaft diameter, and 750 mm under-reamed LB. Sorry, this is DB, and this is D, and this is L, and this is LB. Right? Uh, okay, it is the saturated silicate clay. Under-reamed shear strength is 50. They did not say it is varying, so it is uniform. So you can take average also as 50. Addition factor alpha, and applicable bearing capacity factor is NC is 9 to counteract the impact of soil swelling on the structure constructed above. Neglecting the suction and the contribution of the under-reamed, neglecting the suction and contribution of the under-ream to the adhesive capacity. He is saying that neglect the suction. There will be, see, whenever you pull, there will be vacuum created below the pile foundation. So that vacuum also will give some resistance. So that you have to neglect, and contribution of the under ream to adhesive shaft capacity. Means adhesive means friction. He is saying this portion you neglect that addition. So you take only above and below. That is what the meaning. So what would be the estimated ultimate tensile capacity of the pile? So we know. So we'll just note down values. You know L 8 meters. You know LB 0.4 meter. You know D 0.35 meter. You know DB 0.75 meter. Okay, and you know alpha is given 0.3, SU bar or SU equal to 50 kPa. Okay, bearing capacity NC is given as 9. Okay, control C, control. So anything else which is given? I hope I have written all the given data. So what is the formula? Uplift capacity. One is from the friction. Friction will be alpha SU bar pi dl, means L minus LB. right? Plus due to weight of the foundation is also given, no? 20 kilonewton. Okay, W is 20 kilonewton. Plus due to the bearing at the under CNC 5 by 4 dB minus d square. So you know every value. Can you substitute and tell me the answer within 2 minutes, within 1 minute? So I am also doing along with you people. Can you please tell me? C means SU. Remember, in clays, C is equal to SU always. S- 201. Somewhere something is going wrong. Which area? Yeah. Right. Sorry. 5 by 4. Yeah, correct. So tell me now. Perfect. Answer is coming out to be 300.85 kilonewton. So nearly you can say 301 kilonewton. Integer, nearest integer. So if you see the options 301, okay, this is the answer. But in key paper you might get B as the answer, but B is not the answer. This is the answer. So this is all about the under-reamed pile foundations. So is there any doubt? Can we close the session? So this is the end of the class. Thank you. So I'm closing the session then.